The World of Commodore. The World of Commodore show was a rather large annual event that took place in my neck of the woods through the 80s and early 90s. And even today, the World of Commodore event continues, thanks to a very vibrant retro computer community and the dedicated efforts of TPUG, the Toronto Pet Users Group. On December 9th, 2017, I attended the World of Commodore 2017. Gone are the days of large convention center expos drawing thousands of people and hundreds of vendors. As big and as exciting as those shows were back in the day, I do enjoy the contemporary distilled version of the World of Commodore, where there's still lots of exciting things to see and hear. Whoa, hold on. This is fun and cool stuff. It really is. But for me, what I most enjoy at these World of Commodore events are the presentations. And this year there's somebody very interesting I want to hear speak. Francois Leveille, better known as Eslapion, or Eslapion in my lazy English pronunciation, who is the developer of the PLAnkton, the Commodore 64 PLA replacement. Okay, so a little backstory here. About 6 months ago, I had a Commodore 64 on the bench that needed a new PLA, but I didn't have any spares at the time. So I started looking more deeply into alternative replacements. And yes, I know all the big PLA replacement players were already on the scene with their designs. But, inspired once again by Gadget UK's videos, I decided I wanted to make my own DIY PLA replacement using a specific one-time programmable PROM just like he did, and I would try my hand at making my own pinout adapter PCB to work with that specific PROM. For starters, I came up with this small footprint 2-layer PCB design, basically just an adapter to convert the pinout of the AT27C512R IC to the standard Commodore 64 PLA socket. Of course, having delusions of grandeur, I named my little PCB Replacement 64. See what I did there? Of course, I ordered some prototype PCBs, as well as some of the very specific Atmel 45 nanosecond PROMs, and all that was left to do was assemble and test. My little replacement 64 project board looked pretty, inserted into my Commodore 64 test machine, but would it work? The first test was with the Commodore 64 bread bin with an early revision motherboard, and everything appeared to work fine. But when I started to test later revision boards, it was a different story. This is a C64 bread bin with a later revision 250425 motherboard, and it does not like this DIY PLA replacement. Ladies and gentlemen, I present to you the Kuforg 66. After some more tinkering and testing, I really wasn't happy with the results I was getting, and to be honest, I was getting a little discouraged, so I ended up shelving this project. Fast forward 4 months and I find myself at the World of Commodore 2017 waiting for none other than the creator of PLAnkton, Commodore 64 PLA replacement, to speak. I hope to learn more about the PLA in general, shedding some light on my difficulties, and to learn which alternatives work and don't work. What follows is Francois Leveille's presentation, The Plain Truth About the Commodore 64 PLA, at the World of Commodore 2017. The presentation runs about 28 minutes and it does get a little technical at parts, but if you're a retro computing fan, and in particular like to repair Commodore 64s, I'm sure you'll find it very interesting, just as I did. And please remember, all opinions expressed in this presentation are that of the presenter, not of me or of this channel. Enjoy.
Is used in the Commodore 64 is equivalent to a programmable logic array 24L8. That is, it has 24 IOs. Actually, 16 are inputs, 8 are outputs. It was used in PET computers to complement 74 LS logic ICs. Just like in the 64, its function is to integrate, to prevent having a mass of discrete logic ICs that consume a lot of power. It was not used in the VIC-20, which is apart from the presence of a color video chip, is actually a much simpler computer than later generations of PET computers, as far as I can tell. And the original Commodore 64 PLA was a programmed 82S100. But the Commodore 64, of course, became very successful computers, and it was produced in millions of units. So Commodore, to save money, decided to make their in-house version of the chip. Some of the generations were called the 7700-01. Later generations would be called 8700-01. And the person who knows the most, the person that I know who knows the most about the transition from using a chip made by an external company to Commodore making their own model is Thomas Giesel, aka Scope. Is that a familiar name to any of you? He published a very important document called the PLA Dissected. Now, whether you have an 82S100 in your hand or Commodore's own version, both consume approximately 100 milliamps on the 5 volt. So that gives a total heat dissipation of 500 milliwatt, half a watt on such a small surface. No cartridges attached to the 64. What you will get is not 5 volt. It's going to be lower than that. It's going to be between 3.5 and 4 volts. And it's going to take me a while to get there, right? That's considered to be a logic 1. The input thresholds of the PLA is also within TTL levels. And that means anything above 1.3 volt is considered a logic 1. And anything below is considered a logic 0. The response speed of the PLA is much lower than 74 LS chips, up to 3 times slower. So even though it consumes a lot of power, it's not very fast. The PLA uses only combinatorial logic, which means that for every single specific input, you will always get the same result. There's no registered logic. RC filter added to the CASRAM output, which is pin 18 on the PLA, to all these boards. Otherwise, access to DRAM would be problematic. This information also comes from Thomas Giesel. When Commodore decided to make their in-house version of the PLA, they made some error in the chemistry used, and this causes the chip to essentially self-destruct from the inside. And as I said before, this is a chip that dissipates half a watt of heat. So if you leave a Commodore 64 running, especially older ones, running all day long on a very hot summer day, very often PLA will fail. Since the PLA is essentially a 24L8 programmable array, it has more programmable equations than a PAL22L10, which is a standard chip. But you can combine two PALs, and yes, it will work. And the real PLA sold by Thomas Giesel does precisely that. Is it possible to use modern programmable logic? It's possible with many conditions. Because among the modern programmable logic ICs, there are very few which still operate at 5 volts. But it also happens that if you have something with 16 inputs and 8 outputs that always provides the same result given a specific input, well, it's just the same as a memory chip. But memory chips are not designed to be used as logic chips, and most will cause garbage on transitions, with a very few exceptions. There is one exception that I know for sure, and it's this chip, which I've been talking about for years on various forums. And this chip can do this because it has a very slow output transition rate, a very low slew rate. The M27C512-90B6 is usable as an ordinary PROM, an ordinary memory chip. You can use it to install GFDOS in your 1571 or your 1581, but it works perfectly as a PLA substitute. And in 2008, I was still at university and studying electrical engineering. And we had access to enormous Tektronix logic analyzers that had 32 inputs, and they were running Windows 95, which you couldn't change, by the way. It was a special version of Windows 95 installed in there. And they had a sampling rate of up to 1 gigasample per second. And I brought my Commodore 64 at school, and I installed this chip with the proper adapter and tested how it reacted. And I was amazed to see that there was, on the logic analyzer, there were no glitches at all. And I could not figure out why, until I analyzed these signals with an oscilloscope. And I realized that when the outputs changed from 0 to 1 or 1 to 0, the transition was very, very slow. So if the logic system inside the chip was to generate any glitches, they were essentially filtered out. This chip, when used as a PLA, consumed 8 milliwatts of power. It's 8%. It doesn't produce any heat at all, and it reduces the power consumption of your Commodore 64 by 92 milliamps. It reduces the load on your power supply by approximately 10%. So not only do you have a Commodore 64 which eats less, you reduce the chance of damaging your power supply. But of course, these big special machines, they were in a classroom, and it was not possible to bring outside the classroom any of the captures. These were not fitted with USB ports or anything that could have allowed me to bring the results of my research outside, except perhaps if I had had a very good camera to capture, to photograph the screen. But as soon as I began talking about this potential solution on various forums, especially on Lemon 64, I was immediately targeted by a special character whose name is Gropaz, and he posted that this chip was generating bus contentions, and I didn't understand what he meant by that. But what he meant by that is that The PLA in the Commodore 64 is essentially a traffic cop managing an 8-way crossing. There are 8 outputs to the PLA, and each output signifies this has access to the bus, this has access to the bus. By 2011, ST discontinued this chip, so you couldn't buy it anymore. When it was available, I remember buying more than 100 of them for $1 each. Not only was it discontinued by ST, but it seems that knowing that it could be used as a PLA caused a demand for the chip. And if you go on eBay and try to buy an M27 C512 90B6, what you'll have is a fake. And the original is easy to recognize because the ink on it has a very low contrast. And the pin 1 notch has a very special shape. These fake are actually WinBond proms that have been rebranded. According to this 3-letter code here, this chip would have been made in Malaysia. ST never made any of these chips in Malaysia. So you can't get it anymore, and if you try to get it on eBay, well, you get a bad surprise. If you have an EEPROM used as a PLA in the Commodore 64, and you have bus contentions, this is an output from a logic analyzer, and it was actually done by people in Germany. You see multiple outputs going low. Everything in the Commodore 64, the RAM, the ROM, the signaling is active low, which means if you get a 0, it means it's okay to output. And you see that you have multiple zeros here, and the worst is here. This is essentially a PLA telling everyone can talk. So this is what we call a bus contention. And this is what you get if you use just about any standard EEPROM of the 27 C512 family and try to use it as a PLA in a 64. Now, I know of 2 ways of detecting glitches or bus contentions generated by whatever problematic PLA. You can use a logic analyzer, like on the previous picture. You can use this small circuit connected to the cartridge port. If you don't have any cartridge in the cartridge port, after the Commodore 64 has powered up, when you power up the 64, it will check if there's a cartridge plugged in. But once that's done, these 2 lines should never go low. As simple as that. And if they do, it will turn on the LED connected here. And this resets this LED. So if you have this connected in the cartridge port, when you power up the 64, the LED will turn on because the 6510 is checking for the presence of a cartridge, at which point you press the button. If this LED ever turns itself back on, you have a problematic PLA. As simple as that. The other way that I know, which is much less technical, but requires having something a little bit special, is the Super Exon game cartridge, and not the disc version. The cartridge uses a flip-flop to toggle access between the upper and lower half of a 16 kilobyte ROM. Inside the cartridge is actually 20 kilobytes of code, which is contained in one 4K ROM and one 16K ROM. And because the flip-flop is tied to ROM H, if memory served, if there's any glitch on ROM H, the cartridge will just start displaying garbage, or use the M27 C512 90B6, even though it was essentially a $1 replacement PLA that everyone just had access to. They managed to dispatch, because in the end of the 100 chips I bought, I managed to sell 75, and in the end, last year, the 25 last ones that I had, I traded to Ray Carlson in exchange for a Commodore 64C main board. Nowadays, Tiny software on their website is suggesting that it's a good idea to build your own little board here and put on it an Atmel 27C512 45 PU and use it as a PLA replacement. But GROPAS isn't saying anything. And me and a lot of other people have tested the Atmel PROM, and it generates massive glitches and bus contentions. But GROPAS isn't saying anything because GROPAS is the friend of Jens Schoenfeld. And Jens Schoenfeld wants to sell you a super PLA. And what happens when you build this and try to use this as a PLA, a lot of cartridges don't work anymore. And initially, a lot of people will think their cartridge board has a problem. But the problem is with the PLA. And when people get tired of this, because they realize there are more subtle problems, which I will show you, then they want the good thing, and the good thing is supposed to be the super PLA. But the super PLA has problems. If you want to use a modern logic IC as a PLA substitute, here are the requirements. It must be TTL level compatible on inputs, which means if it receives a signal higher than 1.3 volt, it must be considered a 1, not CMOS level. CMOS level is anything above 2.5. It's not the same. It must have a small hysteresis on inputs. Otherwise, fast load and any other cartridge that uses the same timing trick, it will fail. Because fast load uses a large capacitor as a form of timing trick, but it's not the only cartridge to use that trick. It must respect CAS/RAM timing constraints. CAS/RAM is a line which is essential to DRAM access. And it's because these timing constraints are not perfectly met that boards 407, 425, and 466 have the extra RC filter, which I mentioned earlier. These are R42 and C204. They don't exist in the original Commodore 64. They only exist on later boards. Preferably, it won't generate heat. And preferably, it will not be oversized and cause physical conflicts with surrounding components. There's a new modern requirement. If you are to make and sell PLA substitutes on the market, now all the components you use must be RoHS compliant. Reduction of hazardous substance. Yes?
Does that also apply to solder them to the board?
If you're to sell the product, everything must be RoHS compliant. No lead, no cadmium. Here's a list of a few products which use modern logic ICs as PLA. This is real PLA. This is actually a new version of real PLA because the older one used a pair of dips. This version uses surface mount components, and as such, it still is slightly oversized, but much less than the previous version. It uses two different logic chips in order to be able to replicate all the equations, the logic equations in the Commodore 64 PLA. The Super PLA uses the old Mac 210. Does anybody in here have a CyberGrafx 64 for the Amiga? You do? The CyberGrafx has two of these chips on. So these chips, you see -12 here, that doesn't mean it's 120, it's rated for 120 nanosecond, it's rated for 12 nanosecond. It's a very, very fast chip. And it runs at 5 volts. The Super PLA V3, as you can see, is oversized. So it causes physical conflict on some of the motherboards. It's, I don't think it's usable in the SX64, but I could be wrong. And the Mac 210, well, that's an old chip. It was discontinued, I think, around 1999 or 1998. You can't buy this anymore, and it's not RoHS compliant. There's lead in there. PLAnkton uses the modern XC9536XL. This is a PLAnkton. This is an older version of the board. The ones I have here is a newer generation. And it meets all requirements, but it has something that some people may think is undesirable. It runs at low voltage. Now, a lot of people think this may be a problem because they assume that since all the chips in the Commodore 64 are powered at 5 volt, that they also signal at 5 volt, which, as I said earlier, is not the case. In original Commodore 64s, every integrated circuit is designed to communicate with TTL levels in mind. And this means that anything above 2 volt is considered a logic 1. So, in theory, I could run PLAnkton at 3 or 3.3 volts, but I choose to run it at 3.7, and I'll tell you later why. Most of the other solutions I have seen, including the older XC9536, not XL, don't meet the timing constraint for CASRAM. And actually, I found something rather amusing. If you go on eBay, there is this gentleman called Admiral Decker, and he sells a PLA substitute. But he sells his PLA substitute with a resistor and a capacitor. And he's telling you, if you have this and that and this and that board, you have to add these components to solder them yourself. Actually, he's telling you to do what Commodore engineers did with boards 407, 425, and 466, that is to add an RC filter manually. Of course, you have to have a certain safety margin, so usually manufacturers of TTL chips will guarantee you that the signaling a 1 is done at 2.7 volt or above, and signaling a 0 is done at 0.5 volt or below. And you can see something similar here on 5 volt CMOS chips. They signal a 1 close to 5 volt. They signal a 0 close to 0 volt. But anything above 3.5 volt is considered a 1. Anything below 1.5 volt is considered a 0. And you can see here, this causes a potential conflict. Well, what are the next steps? Recently, I exchanged with Fredric Blåholtz, E5 Frog, who designed the PCB and the VHDL code for PLAnkton. And we decided to turn the joke a little bit on Mr. Schonfeld. We know of the problem with fast load and the problem of the CASRAM timing of the Super PLA. So we offer you SPLAF, which is the Super PLA fast load fixer. It's a little daughter board that you can put under the Super PLA, and it will do two things. It will provide hysteresis on input, because the Mac 210 doesn't have hysteresis, and that's what makes it incompatible with fast load. It will provide hysteresis on the input lines coming from the cartridge port, and it will add the necessary delay on the cast RAM output, making the Super PLA V3 as good as PLAnkton, except it doesn't consume as little power as PLAnkton. And the other the new development is PLAnkton. It's a replacement PLA for the shortboard, which has a much larger PLA because Commodore integrated a bunch of glue logic into the PLA that is inside that computer. Just crash until it goes game over. But you see the scrolling, there's nothing wrong with it. The colors are okay. No problem in particular. This is an ordinary EEPROM used as a PLA substitute. And as you can see, I started the 64. All the startup message is okay. There's no error, there's no color problem. I mean, nothing that could make you suspect there is any problem.
Is this the same EEPROM PLA that you were making before you did the PLAnkton?
No.
Okay.
This is an ordinary.
Okay, because I got one of them, the old ones that works great.
This is problematic. Okay? But you can't see the problem. But that is until you try Super's Exon with it. At this point, you don't see anything wrong. Okay, you thought it was good. And this is actually what Pinamouth software is encouraging you to do. You think it works, but the day you use a cartridge, you got a problem.
Are there any other cartridges that give it the problem?
There are many, but I don't know them by heart. I know it's a problem also with the 1541 Ultimate families of cartridge. But what I'm going to show you now is ST's PROM that I talked about, and Gropaz told you not to buy because it was going to cause a nuclear explosion. $1 US. We go to the basic first. Works fine, just like the other EEPROM. $1 PLA replacement for you. So my point is, everybody could have had a PLA substitute for $1 just because one man in particular is a very good communicator and he didn't want people to use this. He convinced everyone to steer clear of it. The only person, I have two here, but I want to keep them. The only other person that I know has the real thing in stock, not the fake ones on eBay, is Ray Carlson. So my point is, I can sell you PLAnkton and it works real well. It does as good a job, but I would have preferred not to have to, because I don't sell PLAnkton to make money. I sell it because I know it pisses a person in particular off. Well, unless there are other questions, that's it, folks.
I was fortunate to have a bit of one-on-one time with Eslapion. I told him about my PROM experiments and showed him my little EEPROM to PLA socket adapter board. I was subsequently schooled by Eslapion, giving me more first-hand demonstrations, showing me why the PROM solution might be a decent temporary replacement workaround, but only a native PLA or genuine 90B6 variant of the ST PROM that he mentions in the video, or even PLAnkton itself, which is 99.9% compatible with all C64 board revisions, are really the best PLA replacement choices at this time. Francois is definitely a passionate guy and is exceedingly knowledgeable about the C64 PLA. I'm happy to have had the opportunity to meet him. If you want to learn more about World of Commodore 2017, I highly recommend that you read Greg Nassau's detailed blog review of the event over at c64os.com. I'll post a link in the description. Greg has created and maintains C64OS.com, which has become an excellent contemporary resource for all things C64 OS and hardware related. I do recommend that you bookmark C64OS.com. You won't be sorry. Okay, next topic, donations. I realize that my retro computing channel is still pretty young and I don't have a Patreon account at this time, but I have introduced a PayPal donation link in the descriptions of all my videos. So if you find that you enjoyed a particular video and you would like to support my Commodore computer rescue and repair efforts, please consider a small donation to the channel. Finally, I'd like to thank a few people. Raymond Negron, Spaceboy G, Greg Nassau, and Gadget UK for permitting me to use their photos and videos in the making of this video. Also, a long overdue thanks to Mermaid for allowing me to use her SID music that you hear in all my videos. And that's it for now. As always, thanks for watching, thanks for your time, and I'll see you again soon.